Yes, thank you very much for that introduction. My name is Seung-jae Baek, and I'm the final presenter. And I do have a huge responsibility to keep the time limit and be punctual. So today I'm going to talk about seawater battery system. So the name itself is very interesting and very attractive. You are developing a battery system using seawater. So those of us interested in ocean definitely would have to use this battery, right? Now this concept was not proposed by us. And this concept actually was known by many before us. 20,000 Leagues Under the Sea. I'm sure that when you were growing up, you read this book in 1869. Jules Verne wrote this book. So there is a captain and has a submarine called Nautilus, and he is traveling the deep ocean. And if you look at the book, I actually do have some excerpt, and front line says, I wanted to make demands only on the sea itself for the resources of my electricity. So basically he is saying that he's going to get the source of his electricity from the sea. So how is this possible? And it actually talks about how the very bottom line says 2.66% of sodium chloride. So this is NaCl. So he basically is saying that he's going to use this sodium in order to generate electricity, and this is 1869. So seawater battery is not something fancy or grandiose. It's basically from the very concept that was introduced in 1869. How are we going to utilize seawater? So that is going to be my topic. So basically, the seawater battery is going to take a form that is quite different from the existing batteries. It's going to use seawater. Now, the existing batteries actually required plus and minus. So here we have a coin cell and smartphone batteries, and also automobile batteries and ESS large-scale batteries. All these different batteries require plus and minus. However, this seemingly common concept or common sense is only relevant to this existing battery. For seawater batteries, this is how it would look like, as you can see on the right-hand side. From cathode and anode, we would be replacing cathode with seawater. So by selectively pushing through seawater, we can charge and discharge. Now, instead of having both a cathode and anode, we would only require one anode. So what this means is the weight and the size of the battery can be halved. So if you maintain the size and the size of the battery as is, then it means that you can double the capacity. And at the bottom, you can see LIB cost breakdown. As you can see, cathode actually takes up the most cost, but because we're going to replace that with seawater, we can save a lot of cost. So we actually import 100% of our lithium, and this is seawater battery does not use any lithium, and therefore we can have technological independence, which is very meaningful. I don't think that I would require to explain all the chemical reactions that's taking place here, but by charging and discharging and by removing chloride by removing sodium from seawater, what does that mean? That becomes desalinated. It becomes desalinated, so it becomes just a regular water. And after the battery is discharged, then at the bottom of the battery, you will see some white powder, and that's sodium carbonate. And this will react with CO2 as they get produced. So earlier we talked about carbon capture, and this can be used for that carbon capture purposes. So again, because you don't need any cathode, you can have the size. And where can you use this type of battery? I think that you can use it for all the transportation modes in the sea. So here we have some rescue equipment, and by pressing the battery button, you can have the power on. And here we have a lot of underwater equipments, and using seawater battery, you can have their sizes or you can extend their operation time. And here we have many other applications, and I think that you can also benefit vessels and tunnels and offshore power plants. Whichever equipment and facilities that require power and electricity, you can use a seawater battery. And I believe that eco-friendly vessels can use the seawater battery for carbon capture equipment and also desalination facilities. I believe that the seawater battery has tons of applications. So seawater battery cell, how is it developed and where do we stand? The battery cell is being developed by UNIST. And at KIOST, we are actually taking the material and we are actually trying to develop a battery that can withstand the conditions of underwater. Now, you may think that you have seen this type of batteries in the past because that is the case because this is because of open water power by MIT. Now, this is a non-chargeable battery, but secondary seawater battery is what we have developed, and this is chargeable. So using the cell, how can you actually make it work so that you can use it underwater? So this is the seawater battery cell, and we call it seawater battery cell, but it cannot be exposed to seawater. You cannot layer them, or you cannot really tell whether or not they have been discharged or charged, and it's really difficult to grow their sizes. So one thing that would come to your mind, one of the concerns that would come to your mind is that once they get exposed to seawater, you would worry about biofouling. So we are developing some solutions to remove those biofouling. And this is a 300 watt seawater battery system. So this is a green box, and you can take it and connect it, and it will be just like any other batteries. You can dip it in the water, and you can do with whatever you want. And the BMS is mounted in the system, and for biofouling, we understand that edge effect is required. Rather, edge effect is not going to be beneficial. So we thought that we would design it this way so that seawater circulation can be optimal and biofouling can be removed. And as you can see from the top center, we've also mounted this battery with electric shock system to promote anti-biofouling. So by circulating electricity from time to time, we can remove biofouling. So first, mud would attach to the battery, and then biofouling would occur. So we thought about how we can prevent mud from attaching to the battery. So using like a cone, we can have it placed between cells. It has to be not too tight, not too loose, but with the right spacing. If you have it there, then it's going to move every time there is a wave, and this is going to help remove mud. And we've actually developed a battery using such solutions and shared it with others so that they can actually try it out. And they complained about the size and the weight. And so we've created this module-like battery. And in a built-in system, we have added many new functions, and we've shared it to field personnel. And they told us that sometimes the battery system can be used in closed atmosphere. So we've also tested out the battery system looking like the top left. And also, bottom left, we've applied ultrasound. So those of you who wear glasses, you can once time to time clean your glasses using ultrasound. So likewise, we've also applied ultrasound to have this seawater battery system mounted in eco-friendly vessels. And we also developed 5 kilowatt seawater battery system, and you can see that from the 300 megawatt, we've grown to 1 kilowatt, and now we have a 5 kilowatt seawater battery system. For anti-biofouling, we have UVC, LED, and where the light reaches, there will be no biofouling problem. And this seawater battery system was tested outdoors and also in an environment with ultra low temperature, as you can see on the right-hand side bottom. So in the process, we realized that it's really important to have industry-university institute collaboration. UNIST, as I mentioned earlier, studied cell materials, and KIOST, as you can see on the right-hand bottom, produced the batteries as if it was a completed product so that it can be actually applied in the field, and the industry can take it and test and develop applications. Now, what are the applications for this seawater battery? In 2020, these are some of the tests and application tests that we have done. So on the left-hand side top, we have a leisure boat, and in 2020, we've actually mounted the seawater battery on that leisure boat, and right next to it, sometimes just like when your battery runs out from your cell phone, you can use additional external battery. So for this trolling motor, we've used the seawater battery as an external battery. And seawater battery was also tested for smart buoy. And also bottom, we have ionic H2 compressor and neutralizing system. For sterilizing and neutralizing purposes, the seawater battery was tested in 2020. And in 2021, we further developed the seawater battery, and we also worked on minimizing the size, miniaturizing the size of the battery. And we've also developed a smart safety bracelet. And for also toys for children, we believe that we can also use our battery. And for also unmanned surface vehicle, we are testing out our seawater battery. As you can see, the applications are limitless. So where else can we have our seawater battery applied? So on the right-hand side, it says, and more. So the session theme obviously is very related to what I'm about to say. I believe that applications are limitless. Again, now is the time for the industry to take this technology and test out and develop various applications, build track records, and also build confidence. If then, I believe that we can develop this seawater-based battery in earnest, and also development